Hello everyone, welcome back to my channel Geography with Sumona. I am Sumona. In today's video, we are going to discuss an important topic in climatology, that is normal lapse rate. So let's begin today's topic. Now let's begin with a simple question. We know that places near sea level can be quite warm, but when we go to higher altitude such as mountain tops, the temperature becomes much colder. So the question is, why are mountain tops covered with snow and ice when the areas at sea level may be warm? The main reason is that air temperature generally decreases as altitude increases. In other words, we can say that as we move upwards from the Earth's surface, the temperature gradually decreases. This decrease in temperature with increasing altitude is known as lapse rate. In today's video, we will understand this temperature change in detail and learn about the normal lapse rate. Now, let's understand the meaning of normal lapse rate or NLR. In short, we say normal lapse rate as NLR. The normal lapse rate refers to the average rate at which air temperature decreases and altitude increases in the lower atmosphere, especially in troposphere. In simple words, when we move upward from the Earth's surface, the temperature generally becomes lower. Now let's look at the standard atmospheric rate of temperature decrease. According to the standard atmospheric rate, the air temperature decreases by approximately 6.5 degrees centigrade for every 1000 meter or 1 kilometer increase in altitude. We can also express this as a decrease of about 0.65 degrees centigrade for every 100 meters. For example, if the temperature at a lower altitude is 25 degrees centigrade, then after going up 1 kilometer, the temperature would decrease by approximately 6.5 degrees centigrade. That means 18.5 degrees centigrade. So the important point to remember is that on average the temperature decreases by 6.5 degrees centigrade per kilometer of altitude in the troposphere. This is what we call the normal or standard lapse rate. Now let's understand why temperature decreases as we move higher in the atmosphere. First, the sun hits the Earth's surface, then the heated surface warms the air directly above it. This warm air rises upward. As it rises, the atmospheric pressure decreases because there is no or less air above it. Due to the lower pressure, the rising air expands. When the air expands, it loses temperature and becomes cooler. So the process can be understood in a simple sequence. First, the Earth's surface is heated. Second, the air above it becomes warm. Third, warm air rises. Fourth, atmospheric pressure decreases. Fifth, the air is expanded. And finally, the temperature falls. This process of cooling of rising air helps us understand why the temperature generally decreases with increasing altitude. Now let's understand the normal lapse rate with a simple calculation. Suppose the temperature at sea level is 30 degrees centigrade. According to normal lapse rate, temperature decreases by about 6.5 degrees centigrade for every 1000 meter we move upward. So, if we ascend to an altitude of 1000 meter, we subtract 6.5 degrees centigrade from 30 degrees centigrade. Therefore, 30 degree centigrade minus 6.5 degree centigrade equal to 23.5 degree centigrade. So, at 1000-meter altitude, the temperature will be approximately 23.5 degree centigrade. This example clearly shows that as we move higher above the Earth's surface, the temperature generally decreases. Now let's take another simple example of a 2000-meter high hill station. Suppose the temperature at sea level is 28 degrees centigrade. We know that the temperature decreases by about 6.5 degrees centigrade for every 1000 meter of increase in altitude. So for 2000 meter, the temperature decreased by 6.5 degree centigrade into 2, which is equal to 30 degree centigrade. Therefore, we subtract 30 degree centigrade from the sea level temperature of 28 degree centigrade. So, 28 degree centigrade minus 30 degree centigrade is equal to 15 degree centigrade. This means that the temperature at an altitude of 2000 meter will be approximately 15 degree centigrade. This is why hill stations are generally cooler than nearby plains. For example, during summer, people often visit hill stations because of higher altitude makes the climate much more pleasant and cooler. Now let's look at some real-world application of normal lapse rate. First, it helps us understand weather and climatic pattern because temperature changes with altitude have an important effect on the climate of different places. Second, it helps us explain snowfall on mountains. As altitude increases, the temperature decreases. So higher mountain region can become cold enough for snow and ice to form. Third, it is useful for understanding cloud formation and rainfall because rising air expands and cools, which can lead to condensation and cloud formation. Finally, the concept is also important in aviation and meteorological forecasting. Understanding how temperature changes with altitude helps pilot and meteorologists study atmospheric condition and predict weather more accurately. So, we can say that normal lapse rate is not just a theoretical concept. It has many important applications in our real world. Before we finish, let's quickly revise the key point of today's topic. First, as altitude increases, both air temperature and atmospheric pressure generally decreases. Second, the average rate of temperature decreases is about 6.5 degrees centigrade for every 1000 meter of increase in altitude. This is known as normal lapse rate. Finally, the most important point to remember is the higher we go, the cooler it generally becomes. This simple relationship helps us understand why mountain areas are cooler than the plains and why the temperature at higher altitude can be low enough for snow and ice to remain. Finally, let's conclude today's discussion on the normal lapse rate. The normal lapse rate is an important concept for understanding the troposphere. It tells us that on average, air temperature decreases by about 6.5 degrees centigrade for every 1 kilometer increase in altitude. This temperature decrease plays an important role in shaping weather pattern and climate condition. It also helps us understand why mountainous regions are generally cooler and why different types of vegetation and ecosystem are found at different altitude. I hope you have understand the concept of normal lapse rate clearly. Thank you for watching my video. If you found this video helpful, please like, share and subscribe to my channel Geography with Sumona. See you in the next video. Thank you.